Introducing fractions. A fraction represents part of a whole or part of a group. These parts must be equal. They have to be equal parts in order to be a fraction. So let's look at two examples. In this example, the hexagon is split equally. So that's a great fraction. If I colored in half of it, that would be 1/2. If we look at this hexagon, it is split unequally. It is not a fraction. It has to have equal parts. For when a fraction is written, the first number on top is called the numerator, which tells you how many parts are being counted. The bottom number is called the denominator, the number of equal parts in a whole. I like to think of the denominator as going downstairs into the basement. So I like to draw my little stairs sometimes to help me remember D downstairs for my denominator. 4/5, the numerator is the 4, the denominator is the 5. Now going back to the definition, it says that it could be parts of a whole or parts of a group. So if we look here, parts of a whole, if I have a whole candy bar and I eat 4 pieces, that's 4 pieces of a whole. Or if I have a pie and I have 2 pieces shaded in, that's 2 pieces of a whole. Well, if I look at an example of a group of things, parts of a group, if I see that I have maybe jelly beans, I eat 2 of the jelly beans, that would be 2 parts of a group. So there's 5 objects and I only eat 2 of them. If I look at stars and I have 6 stars and I want to circle 2 of those, that represents 2/6 or 2 parts of the group. So a fraction can represent part of a whole or part of a group. Okay, you might hear me say proper fraction and improper fraction. A proper fraction is a fraction whose numerator, remember the number on top, is smaller than its denominator, the number downstairs. So if we have 8/10, 8/10 of this picture is shaded in, it's less than 1/2. The numerator is less than the denominator. This is what we would call a proper fraction. If we look at this example, is an improper fraction is a fraction whose numerator is greater. The number upstairs is greater than or equal to the denominator and is 1 or greater than 1. So for example, if I have 7/4, that's an improper fraction. The numerator is greater than the denominator. 7 is greater than 4. That is called an improper fraction. If I see that it's broken down, I have 4/4 here, 3/4 here. If you put them together, there are 7/4. So 7/4 is an improper fraction. Also 4/4 is an improper fraction because it has the numerator is greater than or equal to. So 4/4, the numerator, is equal to the denominator and is 1. If you see 4/4 is completely shaded in, there are 4 parts and all 4 parts are shaded in. So that's 1/2. Anytime you see a number, this is a little trick, anytime you see a number that's the same on the numerator as it is on the denominator, that's going to equal 1, 1/2. So you have your 4/4 and your 3/4. Now the 3/4 would be a proper fraction, but we're here speaking of 7/4. So you have 4 plus the 3, so here's your 7/4, your improper fraction, and you can change it to what we call a mixed number. You can change it to 1/2 and 3/4. And we'll get into that more in the next few lessons. Now, you'll see fractions in a few different ways. One of them is a region or an area model. A few examples of a region model would be fraction circles, pattern blocks, and a geoboard. And we'll be using these things in class to learn more about fractions and to explore them. So let's say we have a fraction circle. These are pretty easy to draw when the number is even. However, when the number is odd, it's a little tricky to make sure those parts are equal. So I've chosen an eighths. I've drawn this in eighths. There are 8 parts total, and I've shaded in 3. So this fraction circle represents 1, 2, 3 eighths. 1, 2, 3, 4, 5, 6, 7, 8. If you look at the pattern blocks, and we have these in class, you get your pattern block out, and this is representing one whole. And then if you split it into 3 parts, and you shade in one of them, you fit it over it perfectly, that would be 1 out of 3, 1/3. So that would be 1/3 because there are 3 parts total and 1 is shaded. If you use your geoboard, we have those in the classroom with rubber bands that you can stretch over it. And I've already stretched some rubber bands, and then I've shaded in 3 parts. 3 parts of 4 parts total represents 3/4. So we'll see these models in class, and they're called a region or an area model, which basically just means a surface area that's subdivided into smaller equal parts. A set model. We will see set models in class. Basically, these are the groups, the set of objects. So here I have 3 objects, 3 parts to my whole, and I have 2 of them are flowers, so 2/3 are flowers, and 1/3 is a sun. This is a set of objects. If I see here, I have 9 circles in my total, or 9 parts to my whole, and 4 of those, 1, 2, 3, 4, are spotted, so 4 ninths are spotted, and then 1, 2, 3, 4, 5 ninths are striped. And this is an example of set models, which basically means the whole is understood to be a set of objects. Another model you'll see in class is a measurement model. There's a few different kinds. These are just 3 of them. We can see that we can use fraction bars, a number line, and fraction cubes. The fraction bars and fraction cubes are very similar. They're kind of color-coded, and the cubes you can snap them together. The fraction bars you just lay out on your desk. So the one whole, you'll have a bar. You're always going to have, just like with the GeoCube, something to compare to represent one whole. So this is your one whole bar. And then you might have your halves, 2 halves. So if you hold up 1/2 plus 1/2, it's going to equal, let me see if you can see that. It'll equal exactly 1 whole, or 1/2. So here is 2 halves equals 1 whole, or 1/2 of a whole. It goes on to thirds, fourths, fifths, sixths, all the way up to 12ths. So there are 12 parts. This little teeny 12th, line it up perfectly. 1/12 is here, and if you lay down 11 more, those would represent 12/12ths or 1/12 if you only have 1. So we'll be using these in class to explore fractions. A number line is a really cool way to use to compare different fraction amounts. If you look at the benchmark 0, half, or 1/2, and a whole, thinking back to your one whole is 1 whole candy bar, 1 whole book, 1 whole. And then you can cut it in half. So you can look at those benchmarks to help you. So 1/2 would be equal to 2/4, which is also equal to 4/8. 1 whole, like I said a couple minutes ago, is equal to 4/4. That number on top is the same as the number on the bottom, so it means it's 1 whole. 1 whole is also equal to 8/8. And when we start exploring which fractions are greater or less than the other, when we compare, this is a really cool way to visually see it, to measure. You can see, let's say we have 1/4 is less than 6/8. And we'll be exploring those in the next couple videos. Fraction cubes, similar to the fraction bars. So the measurement models basically use length. It's when lengths are compared. It uses length to explore and compare the differences in the fraction sizes. Okay, if we want to look at each of our fractions and their name in a singular form or a plural form, we would say that there is 1/2, so there are 2 parts to the whole, 1 is shaded in. Or if I shaded in both halves, I would say 2 halves. This would be 1/3, there are 3 parts in the whole. Or if I shaded in 2, shaded in another, that would be 2/3. So really all of these are going to have your singular form and then your plural form, whether you have 1 or more than 1. Moving down to 4th, we have 4 parts to the whole. I've shaded in 1, so 1/4. Or if I had more, I would say 3/4, 4/4, 2/4. 5th, we say there are 5 parts in the whole. 1 is shaded in, so 1/5, or many fifths. This is the hardest one, I think, to say. I always get tongue-tied. 1/6, or multiple sixths. That one's hard to say, but this means that there are 6 parts to the whole. Here you have 7 parts to the whole, so 7th or 7ths. These are 8 parts to the whole, 8th or 8ths. And it doesn't matter if it's drawn in a circle, a bar, fraction bars, a geoboard, they're all fractions. This is just how to spell each of their names in a singular and plural form. Here are 9 parts to the whole, 9th or 9ths. 10 parts to a whole, 10th or 10ths. 11 parts, 11th or 11ths. And like a ruler, 12th or 12ths. That one's also hard to say. So pay close attention to how many parts are in the whole. That would be the denominator. And then however many are shaded or however many are counted or described, that's the numerator.